Thank you so much. Thank you. That was a very good job on my last name. Thank you. Okay, guys, so let's move forward. Welcome on my presentation, Data Protection API and Data Protection API-NG. It's a talk about the crypto platform in Windows. There's a couple of things that you guys should know about, and that is something that we would like to, do the deep dive into details, yeah? A couple of words about myself. As you see, Paula J, and what I do, I'm the CEO of CQURE. And we've got a pretty nice team spread across 4 locations: New York, Dubai, Switzerland, and Poland. I'm Polish originally, and that's where I technically live on Saturdays. But a couple of words to mention as well. I do perform the penetration tests at our customer sites. Being also a CEO, which is kind of funny, it's tough. But I try to manage the team of 36 people. We've grown a little bit from the last 2 years in cybersecurity. If it's about my background as well, I do have access to the source code of Windows, though this part it's not covered by the access to the source code. Yeah, so I do have like to 99.999%, and eventually that remaining part, it's something that is worth to have a look at regarding the security. So I also happen to speak at the different types of conferences, also Black Hat, for example, or Microsoft Ignite. So all of those, but they always show one simple thing. It's a very nice opportunity to share, and hopefully you will receive this presentation the same way. I'm happy to explain everything that is out there in crypto in Windows. If you will have any questions, let me know. Now, just to give you the background about the subject, because why Data Protection API? Well, basically in 2010 on Black Hat, Jean-Michel and Ali Burstein, they do presented the DPAPI PIC tool to do a little bit around the Data Protection API. And since 2010, nothing really happened. Yeah, so, or I don't want to say nothing because maybe that something happened, but nothing really that much significant that could show us how cryptography in Windows works and what's the flow behind it. Yeah. Now, whenever we are thinking about the whole story of how Data Protection API evolved and so on, that's the platform that has been there for quite a while. But the new crypto NG has been introduced within the Windows Server 2012 R2 and 8.1, but that's something that I would also like to talk about in a separate part of the presentation. Yeah? So this is what gives you the background why the subject is out there, why it's important, because you need to know how your secrets are or are not protected, that's for sure. And the second thing is that within the Data Protection API, our team spent over 2 years reverse engineering the whole platform, and we managed. And eventually, all of the tools and everything that we got, we share. So hopefully, you will find that useful as well. So before we start, a little story, if you don't mind, related with the Data Protection API research. I like to travel to different types of locations in the world when there is no mobile range. That's quite rare to spot, but things like Siberia, things like Alaska somewhere out there and so on, these are the places that are basically worth having a look at. And when I was in Siberia, I was ordering a breakfast pretty much every day in some different places and so on. And every single time I was asking for like scrambled eggs, I was getting an omelette. Or when I was asking for a sausage, then they were like giving me scrambled eggs. So I was literally never, ever having anything that I wanted as a meal. Like, why? But okay, like, why doesn't exist over here? So I was like, okay, I open up the menu. Another time, I'm like, you're already disappointed. And I check out, and there is a cheese sandwich. I'm like, perfect. How wrong can you go with a cheese sandwich? So I got this, yeah? And I'm like, oh my God, that is pretty nice sandwich. Can I please have a ketchup? And do you have a microwave? Yeah, then it's a great sandwich. So what I'm saying is that having this in mind, it's kind of interesting to get into one simple conclusion that in cryptography, definitely we need to search for quite a long time around what's going on, but there's always a hope always a hope that you're going to get what you want. And I was pretty much having this hope on my vacation, but that never came actually. But in cryptography, finally you're going to get somewhere. And that's my point. You need to spend a lot of time on the research, but eventually you're going to get somewhere. So whenever we are thinking about the algorithms that are out there for the cryptography, well, there are a couple of ones that we need to know, and that data protection API is leveraging. And these are things like AS256, CBC, AS256, CCM, etc. That's for particularly BitLocker. But for data protection API blobs, we are using GCM, yes? And that is something that we're going to be focusing on. There's also LSA being used for the keys protection, but within the data protection API-NG, it's a little bit different story because you are using a little bit different algorithms, but this is something that I will mention in the moment of how does it work. Yeah. So let me cover at the very beginning what the data protection API is. In details, and then we're going to get, of course, into techie part. So, classic data protection API, as we describe it, is the one that is used as a crypto platform within Windows, and very oftenly, in order to encrypt data, it leverages three things: password, the data blob, and the entropy. So why we are talking about that? Because every single time within the application, whether if it's Internet Explorer, Edge, or whatever, Firefox, Chrome, you are about to encrypt something and save somewhere, that needs to happen in a certain way. And you got pretty much two choices. Whether you code it by yourself and save it in your own way, and is this a good way? Maybe, it's the best way, who knows? Or you choose the Windows way. And Windows way isn't that bad, but that's why we are here, to listen to all of the different types of pros and cons of what's going on. Yeah? So let me have a look into more details. So data protection API itself, as the way as we have it in Windows in a basic form, it's quite interesting because every single time you store some kind of a secret, let's call it this way, like password to Facebook in a browser, then that particular secret, it's stored as the browser could save it, but it's encrypted in a way how Windows would do it, relying on your password, or technically relying on your password's hash. Now, I'm saying this in a very straightforward way. Of course, there are many more details behind it, which we are digging into, but that's just for the simple introduction. So the stronger your password is in general, the more protected your secret's going to be. We could be thinking, okay, what about the offline access? Yeah? Well, that's the beautiful part of that. If you don't use, for example, hibernation, and you have an encrypted drive, then basically you're not able to get access to or extract the credentials and get access to a particular secrets. Now, just a little bit of an explanation, if you don't mind. And I'm really bad at painting, so forgive me this, but it would be fantastic to explain that in the very, very details of what's going on. Now, we said that the password or secret relies on our password's hash. Now, that's definitely true, but that differs from the local user perspective and the domain user perspective. And that is something that we need to look at. So we've got here a local user, and here we've got a domain user. Yeah, so these are these two things. Now, whenever we are thinking about secret, yeah, that is something that is protected in a different ways. So for the local user, what happens? We have, of course, in a SAM database, MD4s, so hashes of the user's password. But what is happening is that we have a file, particular file, and that file is called master key container. And master key container has key, and that particular key is used to encrypt that secret. So question is, how is the key in the master key container protected? And for the local user, that's nothing but the SHA-1. Yeah? Why like that? Quite logical, because if it's not prone to offline access, if I manage to get access to the SAM database, then I just have MD4, which I have to crack, and then I calculate SHA-1, and then I'm able to get access to the secret. So that's how it's happening. So what we can get into conclusion about that? Well, we could say here that our local secrets for the local users are as secure as our password is. As simple as this, yeah? Let's leave this. This is actually quite easy. So another part, it's the domain user, and that's cool. So we have over here a master key container as well. And within the domain user, we have two ways of storing the confirmation of the identity, so to say. One thing is going to be MD4, which we in ntds.dit on the domain controller. But another one, it's going to be something that is called MSDCC2. And that is a value that we extract from the registry of the local machine, And that is something that we popularly call cache credentials, but these are not credentials. They haven't been even standing next to credentials. This is just a pre-calculated value that when we provide a username and password, there is a function calculated on the top of that, and we compare with this value that is on the registry. Yeah, so quite easy. And based on that, we're able to log on. Yeah. So so that depends on this or on that. So what is the beautiful part over here, that our logon depends on the probability on the password, if it's correct or not. And on the top of that, we've got certain type of a value. It's not this value, by the way, that decrypts or encrypts that key. It's the value that is just used for confirmation. What encrypts or decrypts effectively at the very end, it's nothing but over here, and that's the difference, MD4. Like for the local, we had SHA-1. For this guy, we have MD4. Why like that? Because we have an assurance that MD4 never appears in the computer when the user logs on. Of course, we are not talking mimicas extracting from the memory and all the credentials like that. And we're not talking over here about the hibernation file. We're talking about saving it somewhere in the form of a text that we are able to get access to. And that is beautiful because that MD4, not being anywhere on the user's or server's area, is used to technically, in this case, encrypt the key, master key, to encrypt the secret. Yeah. So this is the flow. So in every user's profile, we've got master key containers, and these containers contain keys that encrypt our secrets. Yeah, to recap. Now, situation is getting a little bit more complex if we look at the details of this master key container. So what is inside? So we could be thinking, so if, just a thought, if I'm using the live ID to sign into Windows, where is my hash? Okay, just a thought. I'm not answering this question now. Yeah, but where is my hash? So if we rely on a password hash, then in such a case, we know that password hash will be the one to decrypt these keys to get access to secrets. So if we do store that in the cloud, question would be, who is able to get access to those secrets? And again, I'm not answering that because it's a very dangerous question. But then, following up, who else then, is there any other party that is able to get access to our secrets this way? And answer is, yes, it is. And this is the party number 3, that is a very interesting key that is used to encrypt, but it's only in a domain, the master keys of the users that are encrypted with the password hash. There is always a second copy of it stored in Windows that is actually encrypted with the public key of the domain. And you may not have heard of that because it's a kind of a, like, we were working on it. Maybe you already seen, like, when we were having conversations about that interesting type of data. But that is something that you can find out in every user's profile within the domain. And that's a little not cool. So let me share with you a little bit of a presentation of how and where these keys are stored. And we're going to be discussing that in details. So here we go. So this is basically a workstation with from Freddy. And over here, we've got something that is called BK Secure. And that BK Secure, as you see, it's something that, it's secure because it's just my company name, but that is something that is actually a public key of the whole domain. Now, every user has the same key. What's the question? That should come next. Where's the private one, right? Who has access to the private one? Because it looks like this guy, not even looks like, I will show you. This guy is encrypting our secrets, everything. Like your private keys for the certificates, your whatever passwords, if you store them on the Chrome, Edge, Firefox, same story, anything like password for Outlook, anything that is actually leveraging data protection API. And I'm not saying it's a bad platform, we just need to be absolutely aware of how it works. For example, KeePass is a good example here. So if you rely on KeePass on single sign-on for Windows, then this is really much what we are getting over here. Demos, of course, will come in a moment. So let's move forward. So this is basically where they are. They are within the users, username, app data, roaming, Microsoft Protect, and SID of the user, and whole list over here. You've got it. If you want to do someone a bad joke, deleting this folder would be definitely a horrible joke, because then this person will not be able to get access to any types of secrets that this person has stored. Pretty funny. Anyway, so let's move forward. So whenever we are thinking about this classic data protection API secrets, this is a little bit of a sum up. I know it's not very unfortunate color, but let me enlarge it a little bit, and it's going to be clear. Here we go. So data protection API classic. So you can see that we are here relying MD4 SHA-1, and eventually, it depends, of course, how the path goes, but there could be a moment where we are relying on the cache logon data. Now, second type of secret, and that is actually quite interesting thing to spot, it's related with something that we call a CRED hist, yeah, like here. And within the CRED hist, this is another file that is within the same area. That is nothing but the history of our credentials. If you ever wondered how could it be that when I set up within a group policy that I shouldn't repeat the same password for the next 20 times or something, obviously that must be stored somewhere, and that is actually stored within the CRED hist file on every user's profile. That file is decryptable with your user's password hash. Yeah, so the moment you change it, basically, you are able to see like, oh, is there any hash that looks similarly? Yeah? And at that moment, something to mention. So let's guys see of how we are able to get access to these secrets in the operating systems way. But before we get that, a couple of words for the introduction. Yeah, so cache logons, basically. Why I'm going to leverage this? I would like to show you one thing that I'm going to technically perform the following operation. I've got a user. User has stored the password in Chrome. When I log on as a user, I'm able to see this password, not a biggie. By the way, offsite comment, any other application can see that too. So if you save password in Chrome, or I'm just giving Chrome as an example, of course, then any other portable apps or whatever, literally whatever you're going to use, will be able to read your password too. Of course, I'm not saying that apps are doing this, but they can without any problem, since they run as you. So just don't do that. That's my conclusion. But in general, what's the point is that I'm going to leverage cache logon data. I'm going to disconnect myself from the network, and then I'm going to update the cache logon data to show you that I'm logging on with a different password, so that you can see that data protection API is actually, in this particular case, prone to password change. And I will not be able to get access to the user's secrets. And then later, we'll try to get access to those secrets. Now, if you wondered ever if the cache logon data is a safe mechanism or not, just a few words. In the Windows XP, it was already quite nice. Though it was relying on that value was called DCC1. It was relying on the MD4 of the username and user's passwords hash joined together, and on the top of that we calculate the hash. Though with and since Windows Vista, there's a couple of changes that were introduced. We call this value MSDCC2, as I already mentioned. This is a result of the function PBKDF2, which is originally used for things like KeePass, LastPass, Vault, etc. Yeah, it's a pretty nice function that is used for encrypting things. Yeah. Now, whenever we are thinking about cracking that, of course it's crackable. It's just going to take a long time, and that's the strength of the solution. So let's dig into a little bit of a situation where we're going to be, of course, analyzing the cache logon data. So let me see. Here we go. So first of all, well, we've got our user's machine, and I'm switching to the virtual machine right now. So that's this guy. Basically, well, let's just go over here. I'm going to go to the area. Let's go to the CQ tools, and let's get into the, of course, let's go to the Chrome pass. Here we go. And what we see over here is the following, yeah? So here we can see that it's just like a Nearsoft tool, which is a Chrome pass, free tool, of course, and you are able to see that the user stored its password. Not a biggie, I mean, that's obvious, I would say. Now, the question is, how can we get access to that while having only access to the encrypted blob of that particular browser? So let's see. So what I will do, and I'm going to use this offline, I'm going to do it offline for the clearer picture for the presentation, to make sure everything is all clear and so on. So I'm going to, well, technically, let's just move forward, restart this box, and I'm going to get into the, well, CD-DVD. That's going to take a small moment, and on the top of that, I will change the oh, here we go, change the cache logon data. I'm going to use for that purpose Mimikatz with our module for changing cache logon data. I don't want to say cache credentials because they're not credentials at the end. Okay, so let's go to the repair mode. Fantastic. Troubleshoot. And then we go advanced options and to the very advanced command prompt. Okay, and then basically, let me just change a little bit of a font because, yeah, that's unfortunately I have no impact for that, but I think something like this will do. Okay, so here we go. Let's go to the D drive and CQ tools. And now we're going to change the cache logon data so that I can log on with the change password so that you will see that that password will not be visible anymore. Yeah. Okay, so let's go into QE Secure Edition and Mimikatz. Here we go. And then basically we're going to do LSA dump cache. And then we're going to do D Windows System32 config. I have to type it unfortunately. And then system. Because this is the place where the boot key is, and the boot key, pretty much any type of a system secret, is the one that is actually encrypting it. And then we're going to do D, Windows, System32, config, and then security. And this is the place where the cache logon data is, /QE, to have it. I think we are all set. So that is positive. We have just overwritten cache logon data. And the very next step that we're going to do, and let me allow doing it now, we will at that certain moment, and I will do it on my side, change the network to technically not connected, so that we are able to log on with the cache logon data. Okay, fine. Yeah, so this one is disconnected from the network. Fine, continue, and then we can move on. Now we're going to see if we are able to get access to those secrets or not, yeah, and eventually who is able to get access to those, yeah. So this is a little bit of a setup. Okay, the reboot is really fast, so there shouldn't be a problem about this. Perfect. I would like to log on to this box with the password that I used before, which is a p@ssw0rd. Yeah, and that doesn't work. But this time I'm going to type Mimikatz. Yeah, why not? And I'm logging on with the overwritten cache logon data. This is a domain user. That's not that much of a big thing as long as we know how the cache logon data algorithm works. So we are able to pre-generate our value. Cracking it, not really. Overriding, always, yeah? Okay, so we've got this. Now let's have a look at what we got with the Chrome pass, etc. Yeah. So question is, of course, what's happening? So now we're trying to decrypt with the current user's passwords hash all the different types of master keys that are out there, and trying, and at the end it will tell us that unfortunately it's not able to do that. And that's quite interesting situation, as we see, because that proves the point that it's not prone to offline access, and when someone is trying to reset our password, this person will be able to access to log on, but not accessing our secrets. Fine. Let's dig into the problem. Otherwise, you wouldn't be here, I wouldn't be here. Yeah. So the problem looks like this. Data protection API with the Active Directory works in a way that technically there is this very specific public key, and of course it's there by the reason, yes? So that particular public key can be used by several types of operations by the domain controller, but in general, that decryption technique by the private key that is in the memory of the domain controller looks in the following way. So the client makes an RPC call to the domain, and then basically what domain controller does, it returns the decrypted master key, which client can use to decrypt all the different types of secrets. We can do it online, but we can do it also offline. I think offline is more juicy because you are dealing with real data, not some kind of a software that is running in the back. So we're going to actually do that offline. Yeah? So what is the situation? That in the domain controller, and if we have a look at the right side, we do have over here, LSAS, who obviously has access to that particular secret, but LSAS has the possibility to decrypt the key that is stored in an encrypted form in ntds.dit. And we've been searching for quite a long, where this key could be and etc. But every type of a key and also data protection API blob has its own pattern. So we found it, and that one is called, of course, $G backup key, and then it has an identifier. This preferred specifies as an identifier. So that's the one that is currently used. There can be many, but that's the one that is actually currently used, yeah? So let's have a look further of how we can extract it from the domain controller. And we could be thinking, okay, what about like hackers? Like, could they be like domain admins to do it? Well, yes, but I'm not saying that we have to be within the attack a domain admin. I'm saying that if you have a bad domain admin that maybe nobody monitors, that will be definitely a person that is able to get access to every single secret of every person within the organization. And that's more of my point here. Okay, so let's have a look. First of all, what we would do, we're going to extract that particular key from the memory. Yeah, and for that purpose, we wrote a tool, and this one is called CQ LSA Secrets Dumper. And CQ LSA Secrets Dumper has one parameter called file. And that particular file, so parameter file, let's do it, and we're going to do exported PFX. We just give here a typo. We just give here a name of the file, and that's pretty much it. So that exported PFX has a certain type of identifier, and that particular identifier that is displayed on the screen, as you see, is the one that is preferred from AD. So this is also what you will find in the entities.dit as a preferred key. So that's the one that is currently used. So if we do import this guy, that's quite interesting. Password is small letters secure. Thank you. Cert mgr.msc. Let's do it. And if we go to the personal, then you see this very interesting type of a certificate that if we have a closer look at what's that, yes, then basically you can tell that it's a very interesting certificate that has like empty to, empty by, and it's already invalid. That's not cool. Why not? Well, do you have any impact on that? Answer is no. So if you generated your domain, if you set up your domain like in 2008 or something, this is the time when this was valid for 1 year up to 2009, and that's it. Yes, we've been to Redmond. In our team, we've got a group of MVPs. We travel there regularly, literally, and that is not something that is about to be changed shortly. Yeah. So you like it or not, you have to live with this. So if we have a look at more details, then we can see over here that it's actually leveraging as well SHA-1. Not everybody will be happy probably about that, but in this area I can tell you that it's not that bad. Could be worse. So this one can be forgiven at some point unless you've got some other standards. But this is of course the certificate that we all have. And that private key that we have just exported will be the one to decrypt, of course, that particular value that was on the client side over here. Yeah, so let's work on that. So how that's going to work? Well, that's going to work in the following way. We need to open up the console as a regular user, and we need to find out the master key that is corresponding to that secret with the password of Chrome. How do we do that? Well, I will explain it verbally because otherwise it's going to take some time. We've got a tool. It's called CQURE DPAPI Blob Searcher. You take it and you run it on a certain folder. You can run it on a whole C drive. By the way, it's a very interesting activity to see how many secrets you've got in your Windows. Yeah, and it lists as blobs. And if it lists a blob from the Chrome folder in the user's profile, I mean, obviously, that's the place. You take that blob, you drop it into some kind of a hex editor, and at the very beginning, not that very beginning, but a little bit farther down, you will be able to see the identifier of the master key. This is how you do it. So that's really the only way that we found out. So I already know which one that would be, but let's have a look at the further different steps. So that particular secret is supposed to be decrypted with this private key on the DC's memory, encrypted with my current password hash. All right? Why like that? Because data protection API cannot understand the clear text data. So I have to encrypt it additionally, so the data protection API says, oh, that's my user's password hash. Let me grab it. Oh, okay, this is how the secret looks like. So let's get into that flow. Yeah. So we're going to get into CQ tools, data protection API, and over here, first of all, what we will need to do, we will need to generate the hash of the current password. All right, that's going to be used for the encryption. So my current password is mimikans, and user. It's not prone to the username, but our tool requires that. And that is the current password hash. Okay, MD4. Perfect. So this is the first parameter that we will need. Another one we're going to use over here a tool as another tool. That tool actually consists of 41 different little tiny tools that we've been working on, but it's very simple to be used right now. It leverages 3 parameters. One, it's the PFX, check. We have this. Second, new passwords hash, check. We have this. Another one is the master key that we will need to use to decrypt it. And that one we don't have yet, but that is quite easy. So we're going to do it like this. Master key ID, here we go. Then we're going to do new hash. And I'm going to just put in what I've got. It doesn't have to be in the order. PFX, another one, and I have over here that PFX. And then we've got file, and that file I will need to grab from the user's profile. Yeah. So let's see where that stuff's going to be. I'm going to technically do %updata %. Here we go. And then we're going to go to Microsoft Protect. And of course, we're going to get into SID of the user, bring it on, and then we're going to find out our key. Yeah. So our key should be somewhere. Let's just go page down, page down. Here we go. That will be this one. I have it marked, as you see, by the other key. And I'm going to shift right click, copy as path, click, and we have it here, file, paste. So what happens is that this generates us another new type of a key. Let me just go to the bottom, this one, AD modified. And this is something that we're gonna rename, yes? But before we do that, that guy needs to be gone. So let me just rename it. Good. Here we go. Yeah, we can leave it this way. And that guy, AD modified, let's just do that, rename. Here we go. Okay, fine. Yep, and what's going to happen over here is that I will need to change here an attribute for the system and hidden. Yeah, that is basically the flow. So let's just copy that, paste, enter, and from now on, we're able, hopefully, I'll just F5, yep, to see the password of that particular user, yeah? So what just happened, to explain, is that we have, by extracting some information from the Active Directory, which is the private key corresponding to the public key that encrypts everybody's secrets within the domain, managed to decrypt a secret of the user. What's the conclusion? Conclusion is that, A, for the local users, our secrets are as protected as our password strength is. For the domain users, our secrets are protected as our password strength is and as our domain admin is, so to say. Which means if you have access to the domain admin's accounts, you have a power, and we all know that, but yet that's just another reason for protecting a pretty nice server type. And a second thing is that domain admins, in general, we all know that they should be logging on only to the domain controllers if there should be in general out there. Maybe they should be basically just password generated, stored in a safe somewhere, and nobody really leverages these accounts. And if it's about the domain controller's backup and access to the offline data of the domain controller, ntds.dit, and that's not cool, is accessible by the boot key, which is in a system hive. So basically, if you want to decrypt the hashes of all of the users from the domain, then you can still do it by, of course, having an offline access to the domain. And this will be also possible to decrypt this backup private key that I was showing during the presentation. So how the domain controller's protection should look like, there are a couple of things to be applied. Offline protection, that's definitely a must. Controlling of who is logging on and what kind of users do you have operating in your infrastructure. In general, code execution prevention, performing the memory dump, etc. And these are the 3 major steps that will, hopefully, keep your domain controller untouched so that nobody is able to extract that kind of a data. Cool. So with this positive accent, let's move to the next part, which is, can we go like farther than that? Can we do a little bit of a bigger massacre? Yes, of course. And I will explain as well how we are able to secure from that. Yeah. So what else can we extract, so to say, while we have these kind of accesses? Well, yeah, we could say like everything that is really encrypted this way. Yes, but I would like to show you this, okay? So that's going to be the flow. So that's another machine. that I have when I found out that the user basically has a possibility, has a key pass, yeah? And I would like to get access to the key pass of the user, yeah? How can we do that? Well, if the user is just protecting key pass with a password, which I believe most of you do, then, well, you can torture a person. That would be pretty much the only way I would believe. But in the other case, if the user is actually relying on the single sign-on for Windows, then that's a good message for you, because then you were like, great, then data protection API comes to place, just another secret. Let's move forward. So what I have over here is, I do have over here the CQ base. That's the database of the user. What I will do over here, I will type the password that I will type in later, so that you see that right now it doesn't work. It's a secure, it's small letters, enter, and as you see, I'm not getting access to it. But what I've got access to, it's the master keys of the users that I'm able to decrypt, because I have this PFX. I already showed you this operation, so now I'm going to shorten it a little bit. And what I'm going to do, so as you see that doesn't work, I'm going to take this master key in the clear text of the user, so this is the one, and I will work on the KeyPass database. Now, KeyPass database works in the following way, yeah? So here, we've got, well, as you see, let me check, not the backup, no. Oh, sorry, not my fault. Let me show this to you again so that we got it. I just want to use this folder. As you see, that's the same. It's the same type of a file. Oh, here we go. That's better. So over here, we've got a protected user key bin, and that's the pure data protection API blob. So that blob is decryptable by the master key that I have. That blob will give me the key, and that key will be able to get access to that database. That's how it works for KeyPass, that's how it works for LastPass, and any other type of a credential manager type of a solution. So what we're going to do now, let's get into analysis, or eventually we got also tools. And within our tools, we're going to be using two tools over here for real. One's going to be and we have a horrible name, so sorry about this, CQDPAPI, whatever, KeyPass DB decryptor, yeah? And CQDPAPI blob decryptor, so these two. I'm going to use the first one first to decrypt that protected user key bin file that KeyPass leverages. But first, before I need to do that, that file itself, it's not only encrypted with my master key, it's also encrypted with the entropy. Remember at the very beginning we said that Data Protection API Classic sometimes can use entropy. Entropy is a little funny if you have access to the machine, because entropy is saved always in a form of a clear text for this kind of solutions. So whether I read it from the tool, from registry, etc., then, I mean, it makes things complex, but only if you're dealing with a pure data. But if you have a context, it's just not a complexity over here. So let's just move forward. So we're going to do CQ, let me just enter, here we go. CQ Data Protection API. Let me just enlarge this. Okay, better. Data Protection API blob decryptor. That takes as a parameter master key. I have that. Entropy, I don't have that, and blob, I have that. Okay, so let's get the entropy first. CQ, and that's another tool, KeyPass DB decryptor, and this gives us an entropy over here. Yes, this is an entropy of KeyPass. Fine, so what I can do, CQ Data Protection API blob decryptor, master, and I have it because I already copied that. Fantastic. Then entropy. Okay, let me take this, enter, fine, and we're going to specify over here another part, which is, of course, the blob, yeah? And our blob is in the C, analysis, and the protected user key bin. Fine. Yep, great. So what happened is that we have right now that decrypted the key that is used to encrypt the KeyPass database, yeah? So here we go. Next stage, the very last stage, is to CQ, and then we're going to do our KeyPass DB decryptor, and that takes two parameters, key, which we already have, and the file, which we already have because it's our KeyPass database, yeah? So let's move forward, K for key, and then paste, and then we've got file, and then we're going to do C analysis, and this is our CQ base 1 KDBX. Perfect, that changed it to CQ base 1. So let's have a look of what we got. And we've got the CQ base, enter. So it opens up that, and if I try to type the password secure again, because we were encrypted, then basically we're able to get access to the key pass. Yeah. So this is the power of having the full data protection API platform reverse engineered. Any type of a secret really that you save that is saved by using the Windows platform is pretty much decryptable this way, yeah, especially by the domain admin. Now we could just play even more, yeah. So technically, if we do have this particular master key, which we had in the text file over here, then we could get access to, not this one, we could get access to, well, all of this type of secrets. I have for you just another example, just to give you the background that is working for the remote desktop connections part. And if we get into tools, then I've got over here another one, which is related with the RDC, or RDP or RDC for the massive blob files. Yeah, so let's just get into the RDC. Here we go. This is this one, and it takes file and master. So not a big deal. We can technically use that master, and then we specify that. We paste it, and then we do file as well, and then we do C analysis. Here we go, and then we specify, of course, our secure connections. And then these connections they can contain saved username and password. So if you do use RDC connection manager, yes, then basically all these passwords, they are decryptable. Just know that, yeah. Okay, so this is this part, yeah. Now question is there any other place where the data protection API works? Of course, we've got users-related data protection API Classic, but we've got also system ones, and that's cool. System meaning every single thing that you save within the operating system as a secret is decryptable by yourself, and it's also prone this time to offline access. So if you have access to the disk, so to say, then you are able to decrypt all these different types of values. And there are so many places where the data protection API system is actually working. Let me show you how you are able to leverage that by, for example, getting into such a simple thing like, let's say, IIS. Yeah. So that's going to be the flow. So what we're going to do this time. So what I have, and I'm going to, let's just get into the full screen. What I have over here, it's the script that I'm going to use in a second that is allowing me to extract the value from the registry that IIS uses for the centralized certificate store. But first, context is missing. Yeah, so let's dig in. So within the IIS, what is nice is that since IIS 8, what you've got, it's the possibility to configure centralized certificates. Yeah, these guys. Now, centralized certificates are quite cool because you are able to, update all the PFXs within one central location, and then you don't need to import them in the personal container of the server. There are pros and cons for that, don't get me wrong. One of the things that are not that cool is that if you do configure those, so I'll edit feature settings, you probably already noticed that I didn't select any of those certificates on the left, in the left top corner. I didn't. And I have here in the bottom the possibility to configure the password for the private key. What does it mean? What's the problem? The password is the same. Yeah, that's the thing. So you could be like, oh, wait. Yeah, I have like 100 HTTPS websites. Does it mean that all of these PFXs have to have the same password? Yes. So you choose, okay? No comments on that. So what I'm going to do, I'm going to update the password, whatever. So I'm just going to specify some kind of a password. That's really dodgy in IIS. I love IIS, don't get me wrong, I really do. But that thing is weird. IIS always stores settings in the configuration files. Yeah, it used to be like that historically. You've got right now application host config, you've got web config, you've got machine config, etc. So it's config. But then, ding, suddenly this value actually goes to registry. So I don't know why, but this is how it is. So, okay, that value has been updated. Now, the question is, how can we leverage this? So that value within the registry is actually within the local machine. So we can get there, get particularly there. So we can get into the local machine, of course, and we can get into software. Then we can get into Microsoft, and we can get into IIS. Here we go. And we can get into central cert provider. And basically what you will see, is that they are the values that we are looking for. These are the ones, especially the one second from the bottom. It says private key password. Nice. Looks like base 64, smells like base 64. It's not a base 64. Well, it is, but underneath there is a key that is encrypted, and they chose this way to save it because base 64 is absolutely smooth if it's about processing it through different types of tools. Yeah. So what are we going to do? We're going to take this value and we'll try to decrypt it. Now, with what keys and how? Well, if we do look at the architecture of the IIS, and let me technically get into that area for the moment, then it's quite clear who would know where the password is. So we've got user mode and kernel mode, putting this in a very schematic way, http.sys, and we've got SVC host. SVC host consists of two services, Worldwide Web Publishing Service and Windows Process Activation Service. Both of them, they run as local system. I mean, it's just a one instant of SVC host that runs as a local system. And any type of configuration, like for example, in this case, application host config file, is read by that guy. And we're not storing that password in a clear text, as you see. So if that guy reads it, this guy needs to also have keys to decrypt it. So who do we need to talk to in order to fetch that type of information? Answer is local system and local systems profile. Now, IIS, as I already mentioned, is a little weird. So we could go to the local systems profile, or we could ask IIS and say, hey, give me the keys from the container that you manage. It's a little virtual saying, because for real, I mean, you can go to the folder and grab them from there, but it's more romantic to do it this way. So why don't we just do it this way? So here we go. We've got, of course, that credentials or whatever that was secret loaded, and we are leveraging that within the worker process file. So it has to know it. That's the flow. Now, IIS, just to give you the background, uses lots of different types of providers, especially within the IIS 10, there are a couple of new ones. Yeah. So the new ones is the IIS Windows Activation Service only CNG provider and IIS CNG provider, and there are also a couple of other ones that you can use. Yeah. So these are the providers that you, as a developer, ask in order to perform for you some cryptographic operation. Yeah. Let's dig into how we are able to import those keys, and how we are able to leverage those keys in order to decrypt, of course, all that type of a content. Lovely. So let's do that. In order to be able to get access to the IIS keys, there is a very weird tool, which is built in Windows, by the way, which is worth having a look at. And this is basically Windows System 32 iNet SRV. And we've got over here, no, sorry, my mistake, not in this place. Microsoft.NET. Here we go. iNet SRV is going to be in a second. We've got Microsoft.NET. Then we specify, of course, the framework 64. Then we specify the version of the framework, bring it on, and this is where this tool is. This is ASP.NET_rec IIS. Some of you may already know it, but it has the option, it has many options actually, to allow us to not only install ASP.NET, which is commonly used by developers, but from the IT pro perspective, it has a possibility to encrypt some configuration sections, work on the keys, etc. It's a pretty good tool. One of the mistakes, by the way, when we were migrating the server, what we see at the customer side is to forget about the extracting the keys. And then we have to re-enter these passwords again. No, you don't, if you take the keys with you. Now, how do we work on the keys? We have to export them to be able to work on them. Yeah. So let's do that. For that purpose, we're going to use the option PX. Let me enlarge it again. So there is this second from the top, and it says export an RSC keeper, and to the XML, blah, 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 -pri for the private keys. Fantastic. Let's do that. And we're going to, of course, use that particular setup here. And we have to specify the container and the file. What is the container? That's this virtual part of the IIS that is romantic. And we do it this way. So we specify ASP.NET rec IIS, and then we do PX. Then we specify the container. And the container is called IIS was key. IIS Windows Activation Service key. By the way, that's kind of funny because it kind of proves that some people are hungry. Because Windows Activation Service, there is no such a thing. There's a Windows Process Activation Service, but P is missing. So if you just need to, again, live with that fact. In the registry, it has a shortcut WAS, but for real, it's called Windows Process Activation Service. Okay, so we've got this. Now we're going to do ctest.xml, like this. And as we see, we managed to get access to that part, yeah? So succeeded, fantastic, and we got a C-test XML. Great, great. So these keys are there. Now what we're gonna do, we're gonna leverage these keys, yeah, within our PowerShell script. When we've got, first of all, we load it. Second, we specify what kind of provider is used by the IIS, and for that area, there is an LSA crypto service provider used. And then, of course, we leverage that by our key. Yeah? Now, we read the value from the registry. So this is the flow. Second, we do eventually use it and save it within the byte array. And another part, if you are interested, we can display that how it looks like after the decryption, after base 64, so to say. And it looks like Far East, but it's not. It's just an encoding, of course. And if we move forward, what we need to do is this. And I can tell you, that is a little bit of a joke. Because this is why I showed this sandwich at the very beginning, yes? How do you know that you're supposed to revert it? You don't. And we didn't too. And we were fighting for it. And then it's just not happening. But unfortunately, there is one thing that differs Windows from Linux, is that there is no standard on saving data. Whether you use little endian or big endian, like from left to right, right to left, or whatever, I mean, it really depends on who is writing that piece of code. So if you are performing the reverse engineering in crypto in Windows, and you have like 20 levels to pass, and each of those needs to be checked from right to left and left to right, etc. Maybe not that blindly, but sometimes you just don't know, so you have to do that. Then it's a little bit of a freaky situation. So in this particular situation, that is the point that, yep, this time someone decided to write it this way, yeah, because it was Friday, yeah. So here we go. We have to revert it. And of course, at the very end, we are trying to leverage the data protection API system. So once and since we have, of course, all the type of information over here, these keys, etc., then basically, as you see, we are able to get access to this password. Yeah. So this is stored basically in the registry in the encrypted form, encrypted by the master keys of a system, a local system. And because you have access to keys of a local system, you are able to get access to those. Now, who encrypts, by the way, keys of a local system? That's a question. And this is something that I would like to sum up, if you don't mind, for the system part of the data protection API. And who has access to those? Answer is very straightforward. Yep. All of the data protection API system part is encrypted, and it depends on the boot key. Boot key is like a graal to everything system related. And that boot key decrypts something that we call a machine ACC. That's the blue part in the bottom. Machine ACC, it's nothing but a local system's password, which is the same as the machine account password. So when the computer logs onto the domain, it logs on with the computer name and the password of the local system, which is its own password. Yeah. So that password, since you have access to it, you're able to leverage to decrypt all of the different types of master keys that are stored within the profile of the local system. What's the conclusion? Every system's secret is yours. Very easily, online, offline, however you want. So just be aware that every single thing you store as a password, it's out there to be decryptable. There is, of course, TDE encryption within the SQL Server. And this is something that we reverse engineered. Maybe next year we will see each other over here, and who knows, maybe you would like to listen more about the SQL Server data encryption. We have fully reverse engineered that, and it also relies on a data protection API, not a biggie. And anything really that is a system secret is to be, if you, of course, have access to that particular box. Now, summing it up as far, was to summarize, so this green and the purple, hopefully, and the black area, these are the other secrets of data protection API system. So some database entities.dit, that's clear, we already discussed that. As long as you get a boot key, which is in a system hive in the registry, you're able to decrypt those. And also LSA secrets, this is service accounts password, quite easy. If you haven't seen it before, I would... this is too easy to show at this conference, I'm sorry. You have to check out the blog, there's a video. If you type service in my blog, then there's a video how I'm doing this, easy part. Now, cache logon data, it's out there as well. Okay guys, so what's next? Closely, we're getting to a very interesting scenario, which is related with the encryption of the PFXs, PFX files. And that is a new shade on the data protection API, which is data protection API-NG. So new generation, the one that has been introduced in Windows 8.1 2012 R2. Is it used all over the place? No, just for a couple of things. So we still use both of them, and Data Protection API Classic is actually the number one. The NG we use in the major 3 areas. BitLocker, DPAPI and G protected drive, which we already managed to get access to. SID-protected PFX files, which is a fantastic feature because passwords for PFXs, I think someone should go to hell for that, because like, how do you manage passwords for PFX files? There's so many of them, yes, for different areas. So finally, we are able to SID protect them. Great. This one I will show you how to get access to that. And also ASP.NET Core by developers, yeah? So what you see right now on the screen is the ASN format, ASN blob of the PFX file that is SID protected. Now, if you drop it into any type of an editor, this is an ASN editor, simply speaking, you will be able to see that not only we are able to see the blobs, but we are also able to see the SIDs of the user. And it's not just SID that we rely on. No. We rely on a couple of more things, but this is something to be shown during the demonstration. So let me do that part. So whenever we are thinking about SID-protected PFX files, I'm going to leverage for that purpose Windows 8.1, of course, why not? And I'm going to log on as the user. Yeah, it could be Freddy. Perfect. So what's happening over here is I've got a certain type of certificate, and I can do technically export. So let's just do that. Next. Nope, sorry. We have to export it with the private key, obviously. By the way, it has to be made as exportable. Well, what to say? At that certain moment, you can also extract the not exportable private key from the memory. That's the subject for another presentation. Yeah. So here, what we will do, we will specify that we would like to give access to BLE. Next, let's move forward. And we're going to save it as BLE certificate. Yeah, so this will be the file we got over here. Okay, fine. Yeah, so we have targeted that to that particular user. Okay, now if I open this up, next, that shows me this kind of like string here. Yeah, and this is something that I would like to show you how we are eventually able to get access to this particular data. Yeah, so let's see very quickly at how that particular PFX can be accessed by our files. And for that purpose, I'm copying this file out. So there's this BLE certificate on my box, and I'm going to use the local tools to leverage this particular part. What we will need to grab for the accessing this particular PFX, it's the boot key from the DC. And the boot key from the DC, I'm able to extract by using a simple tool. Either, I mean, you can just grab it by any type of a tool, but we wrote a tool for that, which is called CQ Data Protection CQ Secrets Dumper. So let me just mark this guy. Here we go. I'm going to copy this, and I'm going to put it into Notepad on my side. So this one goes out. And we are ready to rock with the getting access to this particular file. Yeah. So let me just bring this up to the field, and we have it. So console needs to be running. Fantastic. And that works this way. Yes. So Data Protection API leverages the KDS keys, Kerberos keys. These are generated at the first moment you leverage Data Protection API-NG. For example, group managed service accounts as well. So first of all, in order to be able to do that, we have to get these keys. And this is to be done by leveraging one of our tools. And let me just show you, I have it already here. I will just type it. Dear NTDS, no, not like this. Dear NTDS. Here we go. And that's going to be our decryptor, yes? So CQ NTDS decryptor, which takes parameters. So one of them is a boot key, and another one is the file, and which is the ntds.dit and the KDS key. Yeah? So we're almost done. So we've got ntds decryptor, boot key, and then we paste it. Let me just do it. Ctrl A, Ctrl C. Fine. Here we go. Then we do file, which is ntds.dit, out file, which is hashes.txt, pfx, which is exp.pfx, and kds root key, which is kds.bin. Enter. Okay, and after the moment, so this particular key is the one that we are leveraging to decrypt the PFX file, or not the whole, not actually, we will need this bigger part. Here we go. And let's get into the decryption. So this is the last operation, perfect, where we're going to leverage the CQDP, API, and so on PFX decryptor, which takes PFX and the master key. And we have both. So let's just rerun it, and we specify over here PFX, and this was our BLE certificate, and then we specify over here the master, which is, of course, the copy of the key that we made, and as you see, it says successfully decrypted the password, which starts with the, what is this, like CTNS something something, and if we compare that with the machine that was out there, just to show you that it's actually the same one, then basically we can enlarge this, and then this is the same password at the very beginning that we had. So this is how you get access to the PFX files that are data protection API encrypted. Okay, guys, so, this is the toolkit, yes? It's even more in progress right now. You will find more information about the tools, etc. on our blog, which is secureacademy.com. You have it in the bottom. This is our educational part. And there's also a quiz if you want to challenge our team on security. It's no registration, nothing, just pure fun. And at the very end, just to sum up, your data protection API, your secrets are as safe as your password is, as your domain admin is, but in the case of a data protection API system, it's as safe as your computer disk is. And during this presentation, what you learned are different scopes of how Windows secrets are protected. It's not a bad mechanism, as you see. It just relies on a couple of components which we need to be aware of. Now you make a decision if you would like to share that secrets with Windows, domain admin, etc. on the standalone computer. As I already mentioned, is as safe as your password is. So if your computer is not a member of the domain, it's not that bad. Hopefully you enjoyed the presentation. If you have more questions, please, of course, feel free to contact myself or our team. And thank you so much once again for coming. And hopefully see you here for questions or for the next part. Yeah, thank you so much.